Okay, hi everyone. We ran out of time in the last class to finish the slides that we were doing on vectors and matrices because there were so many great questions and you were all engaged in the drawing and sketching exercises. So in order to allow us to move on and prepare ourselves for the next lab, we're going to cover this material that we didn't get to in class through this YouTube video. Okay, so basically what we were talking about was indexing or locating inside of a vector or an array a particular value using something called an index. And indices or indexes are numbers that give you effectively the address or location of values within a vector. The counting for an index inside of MATLAB starts with 1 and it's not 0. In some other programming languages, the first value inside of a vector or a matrix or an array has an address of 0. In MATLAB, the very first address is 1, not 0. We identify or tell MATLAB that we want the location, or we want to use the location of a particular piece of data in an array or a vector, and then extract information from that address by using the parentheses. Okay. There we go. So the parentheses, the sort of semicircular brackets, are used after the vector name. So like this, and I would put a number in. Say I wanted the 5th element in there. Okay. I could do something like that. Okay. In order to do this, we're going to try out an example. So here we're setting up a vector called v. So the vector is called v, and it goes in increments of +1 from -5 to +3. So what you have effectively is the beginning and end of a vector. The very first element is -5. The very last element is 3. It is a row vector. In order to determine the very first, or extract the very first value, we say v open parenthesis 1 close parenthesis, and that will take the value at the very first location in the vector, -5, and then return it as a result. It is the first element, the one element, the first element, and it returns the value at that location. So the 1 is being used as an index or location or address, like that. Another way of looking at it is that you could say have houses. And this is the first house. This is the second house. That's the third house, etc. And inside of this house is going to live a person, like that. And that person is called number 5. And over here we're going to have a different person. And that person is called number 4. And then we're going to have another person over here. And this person is going to be number 3, or -3. Okay, so -5, -4, -3. And so we can ask for the individuals located at these houses to come out. And effectively, that's what we did right here. Okay, we effectively took, let me see if I can pull this off. Whoops. Okay, if we want the value of the second element, what we end up doing is we call for element number 2, like that. And so not the first, but the second element will be called in and returned. Now we can also set a value at a particular location. So if we wanted to set the value at address 3, so we want to set the value at location number 3, the third location. And we want to set the value, we want to set the value to 100. So we say v at address 3 is equal to 100. And what will happen is there will be a change in the value at the third location in this vector right here. It will get erased and replaced. None of the other values will change. Okay, so there's another term that's often used because it's commonly used to determine the last value in an array or a vector, and it's called end. And if we do v is equal to -5 to 3, this will set up a row vector like this. And what we're interested in is not the first, okay, not this one. It's this one. Yes, this one right here. It's the last value or the end value. And so what we do is we call it. We say v end, so v with end in parentheses, and we will get the last value right here returned. And that's a very common operation. If we wanted the second last value, so not this one, but this one, so the second last value, we do v, open parenthesis, end -1, and end -1 will calculate the value for end and then subtract from it. And so you will get the second last value, and that will be a 2. If we wanted multiple values at the first, third, and fifth locations, then what we would do is we would say v, open circular parenthesis, then open square bracket, then 1, 3, and 5. And it will request the first, the third, and the fifth elements to be returned. Effectively, it's returning a vector from another vector, or a subset of the other vector as a vector as well. If we want to replace elements, we want to replace the first, third, and fifth elements, first, third, and fifth elements, we can do exactly that. There's that replacement right there. There's that one. And there's that one right there. Now, to reiterate a concept that we talked about at the beginning of the original class, a trivial version or a small version or the simplest possible version of a vector or an array is called a scalar because it only has a single value associated with it. Arrays have more than that. They can be either 1 by 3s or 5 by 1s or 4 by 2s or any combination of these, and bigger and smaller, etc., as long as they have more than one element in them. You can perform arithmetic operations on arrays between both an array and a scalar. So you can do additions, subtractions, multiplications, divisions, etc., no problem between these values, as long as you pay attention to how you're doing it. So here's an example. We set up a vector. Okay, so u is a vector. And that vector has elements 1, 2, and 3 in it. So it has 3 elements in it, valued at 1, 2, and 3. We are now going to add 2 to every single one of these elements. So we add 2 to 1, and we get 3. 2 to 2, and we get 4. 2 to 3, and we get 5. And we create a new vector called w that contains these 3 values. So here we have added a scalar to a vector, and the result is a new vector. Next up, we can do a subtraction, effectively the same thing. So we take the vector, we subtract the vector elements from the number 2. So it's 2 minus 1, and it gives you 1. 2 minus 2 gives you 0. 2 minus 3 gives you negative 1. So the new vector w is a vector with results 1, 0, and negative 1 in it. We can do simple addition or simple multiplication. We can do 2 multiplied by each one of these elements. So 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. 2 multiplied by 3 is 6. Likewise, we can do division. So if we take the vector and divide it by 2, if we divide 1 by 2, we get a half. If we take 2 divided by 2, we get 1. If we take 3 divided by 2, we get 1.5. And so again, a new vector w with the three elements that are combinations of the scalar and the original vector. We can also do exponents. So in this case, squaring. So we're going to do squaring, and notice that there is a dot here. Okay, and we'll talk a little bit more about these dots in a moment. We are going to do a dot exponent to the power of 2 on the original vector u. So we want to effectively square each of these individual elements one at a time. So if I take 1 and square it, I get 1. If I take 2 and square it, I get 4. If I take 3 and square it, I get 9. And now there is a new vector of the same size as the original vector. This new vector is called w, and each of the individual elements within it has been squared. Okay, so we can also take two different arrays, and we can take two different arrays like this and perform math operations on these two arrays together. So we can do additions, powers, exponents, squaring, etc., multiplication, things like that. So here's some examples. Okay, so we can take two arrays, u and v, that have one row in each and 3 columns in each. So they have the same number of elements, 3 elements in each. And if I take a new vector, w, as the addition of the first vector u and the second vector v, I will get 1 plus 7 is equal to 8. 2 plus 8 is equal to 10. 3 plus 9 is equal to 12. Likewise, I can do subtraction like that. 1 minus 7 gives me negative 6. 2 minus 8 gives me negative 6. And 3 minus 9 gives me negative 6. So w is a 1-row, 3-column array or vector that is just like the same size as u and v. We can do multiplication of individual elements, and in this case we need to specify that we're doing individual element multiplication by using the dot right here. So dot star. So here we're going to do 1 multiplied by 7, that gives 7. 2 multiplied by 8 gives 16. 3 multiplied by 9 gives 27. We can do a right array division. Okay, so there are two divisions that we can do within MATLAB. This is one of them. In this case, it will be u as the numerator and v as the denominator, basically. So 1 divided by 7 gives 1.4. 2 divided by 8 gives a quarter. And 3 divided by 9 gives a third. Here's the confusing one. If you do u divided by v, but that slash is the opposite direction, effectively you're doing 7 divided by 1. You're going the opposite direction, basically. It's as if you turned over the numerators and the denominators. So 7 divided by 1 gives you 7. 8 divided by 2 gives you 4. And 9 divided by 3 gives you 3. All right, next up, we want to do u with exponents, and each of these exponents is taken from the vector v. So the first one is 1 to the power of 4. The next one is 2 to the power of 5. And to be explicit, that's 2 to the power of 5. The next one is 3 to the power of 6, and that gives 729. Okay, often when we're dealing with vectors, we need to calculate unit vectors, and you do that by taking the original vector v and dividing it by its norm. So the new vector is going to be u, the old vector is v, and we divide v by its norm, and the norm is a scalar. And that's why here in this division right here, there is no dot. As well, you can compute the midpoint between two other points that form a vector, the vector points that are defined by P and Q. So there's 2 points like this, P and Q, okay? And you want to find effectively this place right here, right in the middle. So you do M, this midpoint, is equal to P plus Q divided by 2, or you could do 0.5 multiplied by P plus Q. You can do dot products as well. So here's one way of doing the dot product. You say dot product is equal to the sum, and that's a function, effectively, of u multiplied by element v. Or else you could say dot product is equal to the dot product function. So this is a built-in dot product function. And the distinction here is that this is a built-in sum function. There are many functions in MATLAB. And either one will give you the dot product. You can apply this to a biomechanics or a biology or a human health application. For instance, you are trying to do the calculation of body mass index, or BMI, where M is your mass in vector form for multiple people, and H is a vector of heights for those different people as well. So you've effectively done a sample of a classroom or a study group or something like that, and you have the masses and heights recorded for everybody in order, your first subject, your second subject, your third subject, etc. And so to calculate BMI, you ask for each of their individual masses to be divided by the square of the height of that person. And you can sort of say it in two different ways. You can also do things like distributions, like bell curves and things like that, on different intervals. So between -5 and 5, and we want a normal distribution, you can define it as such. We've been talking about lin space in class. You could do x is equal to lin space, so a linearly spaced out, I think this will give 100 points between -5 and 5, and then y is equal to this exponential function, okay, so exp, to the, and then what you're doing is you're adding in to this function itself a value, -0.5 multiplied by x, where x comes from your lin space, and each of those lin space values is squared and then multiplied by a scalar, -0.5. And then it's divided, like that, by another scalar, which is defined as the square root of, like that, 2 multiplied by pi. And then you plot your indices, or your indexes, basically, in x, which are defined by your lin space, and your values in y, and it will give you a plot that resembles something like that. And there you have it. So good luck, everyone. We'll see you in class on Monday.